Hello everyone, I'm Ahmed Al-Husseini. I've been an applications developer with the Esri Middle East and Africa Professional Services for 4 years now. Today we'll talk about how to utilize the Python API to monitor your ArcGIS Online organization. In order to do that, we're also going to utilize the REST and JavaScript APIs to do some preparation and configuration. Finally, we'll display the result in an operations dashboard. We think this is useful, kind of an end-to-end scenario here that helps you monitor different things about your organization. Also, very quickly, you'll notice there's another name here, but I'll just be doing the presentation today. While Rami and I both worked on this solution, he couldn't present today. So, a quick run-through of the things that we will be talking about today. I'll start by explaining to you the problem that a client was facing, the motivation behind building this solution, and then I'll walk you through how we resolved the issue from a high-level conceptual point of view. After that, we'll dig right into the code with creating and publishing a new service, in addition to the Python script that does the actual monitoring. Finally, we'll talk about a quick operations dashboard that's displaying the results. So, we have a client that has services and apps that are exposed to the public. While these services and apps mostly don't receive much traffic, they could experience sudden surges of usage. Think of it, for example, like a service to monitor wildfires. While that service would have to deal with a very small number of hits most of the year, when there actually is a wildfire, it'll be experiencing a lot of hits. During one of those surges, the client wanted to guarantee that these apps and services would be available to their users, and that they have optimized their data and applications to load as fast as possible, and to handle the amount of incoming requests. So what they did was that they had shifts of employees logging into their ArcGIS Online organization at the top of the hour, every hour, manually going to each one of the services and applications that they wanted to monitor, taking a screenshot of the usage page, compiling it all in a report, and then emailing that report to the relevant stakeholders. Now, of course, it doesn't really take a genius to see that was very inefficient, slow, and just not the best way of doing things. So they got in touch with us and asked us to help them out. So here's what we did. We used the Python API's built-in functionality to monitor organization item usage, moved those numbers to a feature service, and then built an operations dashboard on top of that feature service. Now, with the task scheduler built into Windows, we could repeat this process every minute if we wanted to, instead of every hour. It would be automated, not requiring shifts of people taking screenshots, and instead of filling up the email inbox of the stakeholders, they could just go to this one destination where they would see all of the information and they could filter it, analyze it, interact with it. They could do all of this interactively. So while that was a quick solution that we had implemented for them, we figured that others could get use out of a similar scenario. And so we changed the Python script a little bit and made it deal with a configuration file that determines which apps and services were being monitored. However, that configuration file still had to be written manually, and that feature service that's kind of acting like our database still had to be created manually as well. So instead of those two things happening, as I mentioned, we built a very simple JavaScript configuration app. Now, what this app does is that it allows you to log into your ArcGIS Online organization and select which services you want to monitor. Additionally, it also created that service that's hosting our information for you, and it also creates the configuration file for you. We also noticed that there were other statistics that could be useful to some users, but we're not in that particular scenario with the client. And so we enhanced our service and our script to include those as well. So let's start with that, the JavaScript configuration application. Let's go through it, and then we can dive right into the code. So the very first thing that happens is that it requires you to log into your ArcGIS Online organization, as I showed you, and you can see here it's trying to ask for permission. So let's log in. Afterwards, it'll take you to this kind of gallery screen with the items that you own shown on the left, and a simple search bar right here at the top. You could select the services and applications that you like, and as you do so, the services are being added to the list of items to watch. Now, if you want, you could click on a service or application that is watched to have it get removed. The search applies to all of the content that is accessible by you for the organization, not just the content that you own. So, for example, this Abu Dhabi hotel service is not something that I own, that is something that someone else in my organization owns and has shared it with the organization. And I could also, if I want, add that to my watch list. Additionally, at the bottom here, you'll see there's a place for you to point to the path of the Chrome driver application. We'll talk about that when we're talking about the Python script. Finally, there's a place that allows you to enter the name of the service which will host the data to be consumed by your dashboard. When you click this Generate Configuration button at the top, it'll generate this new service that you requested and create the configuration file for the Python script for you. All right, so let's see how we did this. So the UI is built in HTML and CSS. We're not really going into those details since you can customize the UI to look however you like. I mean, for this application, we were just trying to do something very simple, very quick. But you could spend, some time, maybe add Bootstrap, use our custom themes, any of this stuff to make sure that the configuration application looks like something that you would like to use. So let's take a look at the JavaScript. That's where the magic happens. First of all, we're going to get some references to the UI elements. We're going to need those later. Then we are parsing the configuration file for the app. Now, all this contains is just, the app ID that is generated by ArcGIS Online when we create an application item. And that's it, really, and just the portal URL of our ArcGIS Online organization. So we're going to use that configuration over here to instantiate a new OAuth info object, and we register it with the Esri Identity Manager. On clicking the Sign In div, we ask the Esri Identity Manager to handle the login for us. Now, in this next block, we check whether the user is logged in or not. If they are logged in, then we show our main UI. So, we set our container div to display to block. And if they're not logged in, that's a catch scenario. Then in that case, we hide our main UI and we show the sign-in div that we had used to log in before. We also handle the option for logging out. We handle that just by calling destroy credentials on the Esri Identity Manager, and we handle the on-click event listener of the generate config file button. All this does is just call this generate config file function, and that's going to be super important. And we're going to dig into it in a couple minutes. But first, let's talk about our search functionality. Very basically here, when you click the search button, we're going to call this function called display items, and we're going to pass to it the value that is in the query text box. And, we'll see what happens with this display items function. So what it does right over here is basically it takes the query, and if this query is empty, it makes sure that the owner is the logged in user. So if you pass in an empty string, so we could try that. If we pass in an empty string, it'll just show me the content that I own. It'll go back to doing that. And then what it does is that it instantiates a portal query params object, passing to it the query and the account ID of the current portal. The main reason that we do that is because we want to limit our search to our current ArcGIS Online organization. Now, if we didn't want to do that, and if we wanted to search all of the publicly available content on ArcGIS Online and, Atlas, Living Atlas, then we wouldn't need this part of the query. There's this account ID and a portal ID part of it. We also set an arbitrarily large number so that we know, our results is going to have a limit of that number. So basically, we're not limiting it to 50 to do any paging or anything like that. Instead, we're just showing it all in the one div. If you wanted to handle paging, this could be how you do that. So we instantiate this portal query params, and we just pass it to portal.query items, And we say, once that portal is done querying those items, then go ahead and create gallery. Create gallery empties the result list and creates a div for each item, in the result set from the search that we performed. We also include a data attribute for the item ID URL of our item that's going to be needed when we're generating the config file. We set the on-click listener of the item to move it from the result list to the item list that we want to monitor. And we also set the on-click listener of the item to be removed from the item list if it's already in the actual item list, if it's already there. Finally, we add it to the result list over here. So with that, we've handled our portal authentication and search functionalities. Now, let's take a look at the actual generation of the config file, because that's the hard part. So first of all, we check that proper values have been provided for the Chrome driver path and for the monitoring service name. Otherwise, we just alert the user and stop the function. If the user has properly provided those values, then we go on. First thing that we do is that we disable the generate config file button so that users are not allowed to click it more than once and just do this process more than once. And then we start putting together the configuration file, the object that's going to become our configuration file. You'll see that we fill out the organization details from the portal information coming in from the Esri Identity Manager and from our config file. And we just leave the password, as enter your password here. That way, that's the only modification that you need to manually make is just add the password to the configuration file. We also take the value of the Chrome driver path, add it to the config file, and we create this empty object called monitored URLs. That's where we're going to be storing those. We then loop through the list in the UI, so the item list div that we have here. We loop through it, through all of the child nodes, and we just add each one of the children to the configuration .monitored URLs, right? We just set the inner text of the child node, so the name of the service, as the key in that object, and then the value is going to be the item ID URL that we had added in the create gallery function. All right, so far so good. We've handled as much of the configuration file as we can, but now we need our monitoring service. So what we're going to do is that we're going to create a request to the REST API. We basically just ask to create a new service for the currently logged in user, with the proper URL, with the proper REST endpoint. And we just provide the necessary parameters. So we define, the token, the output type, the description, tag snippet, and the format of the result, all of that. Now, additionally, we also provide this form data object called create parameters. Okay. What create parameters is that it's taking its service name from the field that we had, for the user to input the service name, but it's also taking this JSON service info and then service details part of service info. This is basically information that's just needed for the service. Now, since most of these values is going to be static and not changing, we just put them in a file over here. Yeah, let me show you here. So see, service details, it's just things like, the initial extent of the service, the units it should be using by default, the spatial reference it should be using, all of that, right? Now, these are just the service details that we are using right over here, parsing. And since they're not changing, we figured just put them in a file, load them in, and then just be able to add them over here when necessary. That way, we don't make our code unnecessarily complex just by including all of this over and over again. Now, after the service has been created, right, we do get this service creation result object, and we take from it the service URL and change it to the admin directory. So we change the REST part to REST admin, and we then go to add to definition. And we make another call to the REST API endpoint now that is add to definition. So you'll see that again we're providing the parameters like the token and the format of the response. But there's also the add to definition parameter in which we define the tables that are going to be in the service. And over here is just the one table that we need to worry about. And it's just the one with the same name that we're using and indices, just to make sure that, you know, we're using the proper index. There's a field that is unique. You know, what should the service basically index by? And again, we're using service info.table details instead of service details as we had before. Again, that's just some static information about the table. You know, which features does it support, all the querying and editing capabilities, etc. The actual fields of the table, all of that. Now again, since all of these properties we're not going to be changing, we loaded them from a file, you know, instead of over necessarily complicating the code. After this table is created, and we get this table creation result, we just take the URL for it and add it to our configuration object. And we call download JSON, which is just a function that we wrote that basically, you know, is going to download the JSON file for us with the configuration object inside of it. We also make sure to handle any errors, you know, and properly alert the user, all of that, and allow the user to call the function again if necessary. Okay, so for example, if a user tries to pass in a service name that has already been created, there's no way for us to check for that until the request has been sent to the REST API, and the REST API comes back with an error. And so we just show that error and then allow the user to, you know, change the parameter and run the function again. Okay, so let's take a look at the configuration file. You'll see that it lists the monitored URLs and all of the other properties that we had set from the configuration application, such as, you know, the Chrome driver path, the organization details, etc. And on top of that, it also adds in that property that's the monitoring data service, which I had properly created and put in the URL form. Okay, so now we're ready to dive into the Python script and actually start doing some monitoring. So we've done some imports here, standard Python libraries. The only one that could stick out a little bit is Selenium over here, the Selenium and its options. Selenium is basically just a library that allows us to open Google Chrome in headless mode. This basically means that while a browser instance will be running and loading the page, it's not in a window that the user can see. We use that in the next function written here, which allows us to get the response time for a given URL. Basically, all it does is that it instantiates Chrome options, you know, and just makes sure that the option for headless Chrome is being given to it. You know, sets a start time, goes and gets the URL, sets the end time, and then just returns the seconds between the start and end time. So we're going to use this function later in the script to get the response time for different applications that are being monitored. In order for Selenium to be able to do that, it will need access to the Chrome driver. That's why we needed to include it in the configuration file. So that's why we have to do that. And you can just download the Chrome driver off the internet. It's fairly straightforward. Just Google it. You'll find it. Now, okay, to the actual function of the script. So we start out by loading and parsing the configuration file, right? First two lines here, we load the file and then we parse it into a config variable here. We then set some variables from the configuration file and instantiate our ArcGIS Online organization. We're also going to put the access token in a variable just so that we could, keep referring to it later. We also store the current time. That's because next we're going to query the feature service for the data that has already been stored. Okay. And from that, we get the latest date that is stored in the data to ensure that we're not repeating data that is already existent in the service. Notice that over here, we're removing 3600 seconds from the current time, 1 hour basically. That's because we want to limit our usage information to the previous stop of the hour, not up to the current hour, where the value would be changing. So for example, you can see it on my screen, it's like 3:10 p.m. We only want to see up to 3 p.m., not in the current changing hour, basically. After that, we go and create a pandas data frame with the relevant fields to us: the date, the usage, the name, and the response time. The usage is just the number of hits that the service has been receiving. For each one of the URLs that we're monitoring in the config file, we're going to basically get the item ID from the string, instantiate an item in our ArcGIS Online organization, get the usage for that item using just plainly item.usage from the Python API for ArcGIS, create a data frame for that usage, and go ahead and fill in the name for it, get the response time for hitting that service or application using that get response time function that we had talked about before, and again setting it for the data frame, and adding the data of this current data frame, for this current monitored URL to our all data frame that we, it basically includes all of the information for all of the apps and services that we're monitoring. And then we're just going to filter this all data frame to make sure that it's that it's greater than the latest date that is already stored in the service. That's why we had calculated it before, and also less than the max date, which is the last stop of the hour, basically. We start preparing our data to be added by the service by creating this request object over here, just setting the format to JSON, features as an empty array, token as the token that we had stored earlier, and setting rollback on failure to false. We put the rows of the data frame in the correct format that's expected by the API, so creating the object with the attributes, all of that, and just adding it to the features array over here. And now we're ready to move on to the next step. Here, we're getting a reference to all of the licenses available or in the organization. This is actually a reference to the individual products. So for each one of those, we check, if it's not a free product, then we get the license report for it, which includes information about the total number of licenses available, those that have been assigned to users and those that are remaining. We create the REST API features with this information and append it to our request. Finally, we add the number of credits available. Also, please note here that we've been adding a property called record type so that we can separate between credit monitoring, license monitoring, and service or application monitoring. Since this is all going in the same table, we do need to be able to separate between the different monitoring functionalities, with a simple where clause. Finally, we just go and, make the request to the API, adding in all of the features. And with that, our data is sitting neatly into our feature service, ready to be consumed by an operations dashboard. Since this script needs to run periodically to update the data, we need to schedule it in the Windows Task Scheduler. So let's open that. And yes, we're in the Task Scheduler library. Click Action, New Folder. I'm just going to call mine Ahmed, whatever. And we're going to click on Create Task. Give our task a name. So let's say organizational monitor. You could call it whatever you want. We want our script to run whether or not the user is logged in. So let's check that. Make sure that it stores the password. That way it's actually capable of doing network requests and all of that. And we're ready to move on to the triggers, basically what causes this to run. So we're going to create a new trigger. And we do want our task to run, on a scheduled basis. We don't want it to run one time. We do want it to run daily, recurring every day. And we do want it to repeat every amount of time within that day. Now, in our case, 1 hour is perfect, but you could change it to 5 minutes, 10 minutes, 15 minutes, whatever you want. But in our case, 1 hour is perfect, so we're not going to change it. We could also have the option to stop the task if it runs longer than a specific amount of time, but that's not going to happen in our case. And we could set the task to expire if we only wanted to monitor it for a specific period. Say, for example, I do know that I will have an influx of users until the beginning of April, and then I no longer need to be monitoring the consumption of the service. Then in that case, I could set my monitoring task to expire at the beginning of April. But again, doesn't really apply to us, so we don't need it. And of course, whether or not the task is enabled, and yes, of course, it is enabled. All right, let's move on to actions. What do we actually want to happen, for that specific task that we're scheduling? So we're going to click New, and we do want to start a program, and that program is Python. Yes, python.exe. Our argument is going to be the actual file that we had written, so usage.py, right? Python usage.py, except, where does it actually find usage.py? It finds it at a specific path. So let's get that path, reveal in File Explorer. I'm just going to take this path here and make sure that that's in my start in field, basically, of the task. Make sure that it is surrounded by quotes, double quotes, if there's a space in the name. So like organization space monitor in the folder here. So, make sure to surround it with double quotes. That way you won't run into any errors. Click OK. And everything else is, good for the default, basically. So start only if the computer is on AC power and stop it if it's on battery power. You might want to change that if you're running it off a laptop. But, something to keep in mind is, of course, this will be consuming your battery. These settings allow the task to be run on demand. Absolutely, whether you just want to actually force the script to run at any given time. And everything else looks good for the default, so we're going to click OK. We are going to need to provide the password so that it gets stored. And there you go, it's done. You've now created your task that is going to be running that script for you. That's going to be storing the data in the dashboard, in the feature service, and we could see it in the dashboard. Speaking of, moving here to this operations dashboard, you can see some of the kinds of things that we can add to learn about our organization. On this bottom chart here, we can see the number of assigned licenses versus remaining licenses for the entire organization. And we could filter for a specific product. In this case, it was almost the same. But we could filter for a specific product. We could see, for example, that maps for Power BI hasn't been assigned to anyone. 3D Analyst, is divided in that way. So that's just kind of the information that we can see for the specific licenses. You can also see the utilization divided by the individual services. Now, of course, you can make this a little bigger or smaller up to your specific needs. The average response time for each of the services that we are monitoring, the total number of hits for the service, the total utilization per hour. This specific dashboard doesn't include, the credits, but you could absolutely include that as well. Get the latest count of the credits, show that, or the credit consumption through time, create a graph. This dashboard, represents just some of the things that you can do. But you have the information sitting in the feature service, and you're capable of determining what are your needs. What are the things that you need to be looking at? What are the things that you need to be monitoring and seeing the consumption of? So these are all things that you could be doing. So with that, we've gone through the application, creating the configuration file that is consumed by the Python script, which publishes the data to an operations dashboard. While that was a specific example, we hope it illustrates the length with which you can monitor your organization to get more insight about your services, applications, licenses, and credit consumption. Thank you for watching, and if you have any questions, please don't hesitate to email me at alhusseini@esri.com. Thank you.